Hubble. The iconic telescope that's opened our eyes to the secrets of the universe. Expanding our understanding about the fate of galaxies. And introducing us to massive forces we never even knew existed. This is Hubble's amazing universe. The most celebrated telescope on Earth never touches the planet. Hubble Space Telescope orbits nearly 650 kilometers above the Earth, racing around the globe every 97 minutes. Its powerful mirror sees it all. Soaring star factories where new worlds are made. The violence of exploding stars. And a new light on black holes. Hubble is the key that has unlocked some of the greatest mysteries of the universe. But now, the telescope is in danger of being lost forever. Crucial instruments have broken down. A main camera and light-splitting device called a spectrograph no longer function. Gyroscopes that keep Hubble properly oriented in space are failing. Worst of all, Hubble is falling. The 12-ton telescope, as big as a school bus, is slowly spiraling toward the Earth. We are Hubble's only chance for survival, but a mission to save the telescope can be perilous.
I don't know if I could ask an astronaut to risk his or her life to go up to fix Hubble. It's a tough personal choice. But if you ask the astronauts, they do not even hesitate.
Astronaut John Grunsfeld was assigned to the Space Shuttle's final servicing mission to Hubble that launched in October 2008.
Up and burning. 2, 1, and liftoff.
Going to Hubble is a calculated risk. Spaceflight is risky by any means. So in the scheme of things, this is something that I've determined, and on behalf of my family, that it's worth risking my life for.
Why is an aging telescope that's nearly reached its 20-year life expectancy worth the risk? Because Hubble continues to astound us with surprising details about our universe, as it has since its 1990 launch. Astronomers have long wondered where stars like our Sun come from. Jeff Hester of Arizona State University knows that stars evolve from clouds of gas and dust. What he hopes to discover is how these clouds give life to stars. Astronomers suspected that the Eagle Nebula might provide clues, but even the most powerful Earth-bound telescopes couldn't get a clear view. Spring 1995, Hester aims Hubble Space Telescope toward the Eagle Nebula. As he downloads his images from Hubble, Hester can hardly believe his eyes. This is Hubble's first picture of the Eagle Nebula, some 6,500 light-years away. It shows 3 gigantic pillars made of gas and dust. The tower on the left is about 4 light-years tall.
What gives them their shape is the fact that fairly nearby there are some very, very massive, very luminous, very hot stars that are dumping out huge amounts of ultraviolet radiation. And it's sculpting the surroundings.
These celestial pillars have never been revealed in such stunning detail. For the first time, scientists see that each pillar is dotted with small clumps of gas. Could such clumps be a missing link in the birth of stars? Hester calls the clumps evaporating gaseous globules, eggs for short. The image reveals that forming inside some of the eggs are embryonic stars.
What we're looking at is a snapshot of a very dynamic process, a snapshot of something that's changing. As part of that change, next generation of stars is emerging. This one, for example, you can see the little red dot in there, which actually is the star. And that one is an especially nice one. The star at the tip of the egg is actually pronounced.
In the photograph, the eggs appear small, but our entire solar system could fit comfortably inside each one. These hot clumps of gas are the first stage of the formation of a star, and the towers where they hang are rightfully called the Pillars of Creation. Hubble's image of the Eagle Nebula shows us an early stage in the creation of stars. What it doesn't show is the next stage, how stars hatch from eggs. That answer came from images Hubble captured in 1994. Some 1,500 light-years away from Earth lies the Orion Nebula. Like the Eagle Nebula, Orion is a birthplace of stars. When scientists closely examined this image, they discovered tiny dark spots. Flattened disks of gas and dust spots created by recently hatched eggs. The spots are called protoplanetary disks, proplids for short. The warm orange clump in the center pulls in loose material from the surrounding disk. This squeezes the matter in the center of the clump. The pressure grows. The clump heats up. Eventually, it will become so hot that it triggers nuclear fusion, and a star is born. Heat and radiation from the nuclear fusion generates a stellar wind, sweeping away most of the loose matter in the disk. But some of this loose matter remains in orbit around the newborn star. Over time, the debris gathers into more knots and clumps, growing and evolving into a planet.
It really is the case that if you could go back 4.5 billion years ago and look at the formation of the sun and the solar system, that it would be that kind of an environment that you would find us in.
Hubble has shown us the genesis of a new solar system and answered an age-old question of how our own star, the Sun, and our Earth came into existence. Beyond the Eagle and Orion nebulae, even larger star-forming regions lie within the plane of the Milky Way. Scientists wonder if the life cycle of stars is the same in these distant regions. In March 2005, Hubble began relaying images of a new target. The Carina Nebula, one of the largest star-forming regions in the sky. But the raw data sent by Hubble looks nothing like this. Creating images that help scientists unlock the mysteries with this data falls to imaging expert Zsolt Live.
I have an emotional attachment to that image, not only because of its aesthetic value, but because of the amount of time I spent on it.
Picture data comes in from Hubble in black and white. Levi assigns colors to these images according to the chemical elements detected by Hubble's instruments. Blue shows oxygen. Red shows sulfur. And green is hydrogen. Levi works for about a year to produce the full mosaic out of 48 separate pictures. Hubble's image of Carina shows a region over 50 light-years across. Here too are the eggs that will one day become stars, encircled by planets. Among the thousands of newborn stars lurks a surprise. Within the cloudy halls of Carina, Hubble detects the death throes of a massive star. For scientists, a dying star is an opportunity to see the future of our own solar system. What these Hubble images show are shells of gas that serve as tombstones. Their quiet beauty is deceptive. These walls of color are the outer layers of a star much like our sun. As a star runs out of fuel, these layers expand until the gravity of the star can no longer hold them. Eventually, they are released into space. In 2004, Hubble captures an image that gives us a glimpse of our eventual demise. The Helix Nebula. As these outer layers of star expand, they leave behind a searing hot ball of solidified oxygen and carbon astronomers call a white dwarf. Someday, the same thing will happen to our own sun. The sun will run out of fuel, and that will cause it to expand into a giant red star. That's bad news for our world. The temperature on the surface of our planet will rise over 1,000 degrees. All life on Earth will perish. A wall of hot gas will sweep over the Earth, through our solar system, and into space. Every planet and moon in its path will be incinerated. The only thing left of our sun will be a splash of color visible from thousands of light-years away. Like this.
So the human race has its warning. We have 5 billion years to clear out of town.
But even the death of our own sun hardly compares to a more powerful downfall. Some stars are over 100 times more massive than our sun. The bigger the star, the shorter its life, and the more violent its death. These stars explode in a massive fireball, called a supernova.
Not every kind of star can explode as a supernova. The sun can't, for example. It just lacks the oomph. It doesn't have the mass that you need to be able to get what happens in the core to make a star blow up. There are a handful of stars in the galaxy that are definitely capable of doing this.
Every star is carefully balanced between the inward pull of its gravity and the outward pressure of the heat it generates from nuclear fusion. When it runs out of fuel, the pressure needed for balance is gone. Gravity now reigns supreme. The star caves in and explodes. The full fury of a supernova destroys the star and everything around it. If the star was near enough to Earth, a wave of deadly gamma and X-rays would flood towards us. It could knock out satellite communications and cause global power outages. In fact, one such giant star has already exploded in our own galaxy. Hubble Space Telescope recorded an image of the aftermath.
The Crab Nebula is the expanding wreckage from a supernova that occurred in the year 1054. The explosion of the supernova was recorded by Chinese astronomers, so we know exactly when the explosion was.
The expanding debris from this 1,000-year-old supernova is still moving into space at about 5 million kilometers per hour. But the image is more than just a snapshot of ancient history. For scientists, the interconnected web-like filaments offer a clue as to the nature of life itself. The basic elements needed to create life are formed in the heart of stars. When the stars explode, these fundamental elements are scattered throughout the universe, seeding distant nebula clouds which give birth to new planets and new life.
The hemoglobin in your blood, when you bleed and it's red, that red color is due to oxygen, and it's due to iron that is in your blood that was created in a supernova. The gold on your wedding ring is created in a supernova. Calcium in your bones was created in a supernova. And so we learn so much about the universe itself when these stars die.
Hubble is giving scientists the ultimate learning experience by monitoring one particular star, Eta Carina, back in the Carina Nebula.
This is a star that is a bit of a mystery. It appears to have about 100 times the mass of the Sun, and that is the upper limit. The more massive a star is, the hotter it is, and the surface of the star is so hot that it can't even hold on to its own gas. It's constantly blowing off a stream of gas.
For over a decade, Hubble creates a series of photos of Eta Carina. The photos show two enormous lobes of superheated gas erupting from the surface. Although Eta Carina is a young star, its huge mass makes it unstable. This star will not survive for long.
Eta Carinae is one of the very few stars that we can point at and say, yeah, that one's going to go.
When Eta Carina goes, it will become one of the most devastating supernovae ever recorded.
When the light from the explosion reaches us, it will be an extraordinary sight. It will be almost as bright as the full moon. All that light concentrated into a point of light in our sky. It will cast shadows at night.
The fireworks will begin when the star runs out of fuel. The gigantic star will destroy itself in just a few seconds. The core of the exploding star will bear the full brunt of the catastrophe. When that happens, it will leave behind one outer space phenomenon that has long captured the imagination of stargazers. A black hole. The mysterious black hole phenomenon is the product of the violent and powerful explosion of a supernova, at least in theory. Before Hubble, there was no conclusive proof that black holes existed at all. The modern concept of the black hole comes from Einstein's theory of general relativity.
If you take matter and you make it massive enough, dense enough, the gravity will be so strong that you will create a region of space that light can't get out of. It truly does make a hole in space. You can get into it, you can't get out of it. Sort of like a cosmic lobster trap.
According to Einstein, a black hole begins with a very large star. It must be at least 4 times bigger than our sun.
A black hole is a simple thing. It is a hunk of matter which somehow has gotten so small that the gravitational field right around it is so strong that light cannot escape from it. So even if it tried to emit radiation, the photons would fall back. They would be sucked back by the gravity of the black hole, and it would look invisible.
During the blast of a supernova, the inner core of a star collapses into a single point, smaller than a pinhead. Astronomers call this single point a singularity. A singularity is an object with no length, width or height, yet it retains most of the gravity of the original star. One of the primary goals for Hubble was to prove once and for all whether or not black holes exist. But how does one search for an invisible point? Astronomers decide to direct Hubble to examine the exact centers of galaxies. It is a wise decision. What they discover is that the stars close to the center of galaxies zoom around at very high speeds. This is not how stars normally behave. Most stars move along at relatively slow speeds. But down in the central hub of galaxies, stars are being thrown around by the gravity of something that is massive yet ultra-compact. There can only be one cause for this effect: the fabled black hole.